Hello everyone, welcome to today's lecture. In our today's lecture, we are going to learn about data transformation technique normalization, and in that normalization we will learn which of the normalization technique is used to normalize the data. But before we start, let's revise our previous lecture. In our previous lecture, we have learned what is data transformation. So data transformation is the process of converting a data from one format to another format. Yes. But and in this topic we have learned there are many data transformation techniques are available, which are smoothing, aggregation, generalization, normalization, and attribute construction. Yes, but there is one technique which is a normalization. So a normalization means a scaled up attribute data so as fall with a small specified range such as 0 and 1. Yes, suppose we have given a data whose minimum value is 302 and its maximum value is 16,502, and our task is normalize that data value into 0-1 interval. So we can do it with normalization techniques. Yes, so in this lecture we have learned three normalization techniques, which is a Meanmax normalization, decimal scaling, and Zscore normalization. So let's start. So the first technique for data transformation by normalization is a Meanmax normalization. Data transformation by normalization or standardization is the process of making an entire set of value to a particular property. Yes. So in a Meanmax normalization, results is a linear alteration of the original data. The values are within the given range. Okay, so this is the formula for the Meanmax normalization. In the Meanmax normalization, some data is given. So the formula is new value or the normalized value is equals to old value minus minimum of the old value divided by maximum value of A. A means a attribute set. A means a set of data. Yes. So max A minus mean A, the maximum value minus minimum value, into new max A minus new mean A. New max A means if there is a old range is mean A and max A, and new range is created. Suppose the example of new range is 3,8. Yes. So we have to normalize our data into 3,8. So here the new range, new max A equals to 8 and new mean A equals to 3 plus new mean A. So this is the formula for a for Meanmax normalization. So our task is to scale the range into a given range. So for example, suppose we have a attribute data. A data has 13, 15, 16, 16, 19, 20, 23, 29, 35, 41, 44, 53, 62, 69 and 72. Yes. Same as our binning methods. If data is not sorted, then first step is sort the data. After sorting the data, we have to create our value, and the question is, use the Meanmax normalization to transform a value 45 to a new range 0 to 1. So here now we have value of our V, old value. We have to normalize that 45 into the range 0, 1. Yes. See, so here our new range is 0, 1. So value is 45, new range is 0, 1. Old range. So to create a old range, we have to select minimum value as the first value and maximum value as the last value. So our old range is 13, 72. Yes. So now we have all the data values. So as per our equation is Vi minus mean A. Vi means our value that we have to normalize. So Vi is equals to 45. So 45 minus 13. 13 means Vi minus mean A. So here Vi equals to 45, mean A means old range of minimum value of old range. So minimum value of old range equals to 13. So 45 minus 13 divided by new max minus new mean. Old max minus old mean. Old max equals to 72 minus old mean equals to 13 into new max minus new mean equals to 1 minus 0 plus new mean equals to 0. Yes, so this is the value. After calculating, it is 32 by 59. So now the generated value is 0.542. Here we have a data value is 45 and our target is to convert it into the 0 and 1 interval. So now after processing this step, our value is equals to 0.542. So this is below in this range. So this is how min-max normalization is done. Yes, I hope now you all are clear with this example. So I again repeat, first we have a data value, from that we have to generate our old range. For old range, first we have to select first value as a minimum value and last value as a maximum value. So this is our old range is created. New range is already given in our question, and value which we have to normalize is also given in the question. So now we have all attribute. Our task is just apply all that attribute into our equation. So as per our equation, this is a new mean, this is a new max, this is a mean A, and this is a max A. Okay, so based on equation, so this is the equation. We have to put all the value into the equation, and finally we'll get our answer in the specified range. So this is how min-max normalization is work. Second method is a Z-score normalization. Yes, in the Z-score normalization, it is depends on the mean value and the standard deviation. Yes, so let's understand what is the equation of Z-score normalization technique. So the equation is V dash equals to value V minus mean A, mean of the data, divided by standard deviation. Yes, so let's understand what is each term. So V is a data value that we have to normalize. Mean A. Mean A means mean value of all data. It is calculated by n by 2th term, and the standard equation of standard deviation is equals to in root 1 divided by n minus 1, sigma 1 equals to 1, I equals to 1 to n xi minus x bar whole square. So here n equals to number of terms, x bar equals to mean value that we have already calculated, and xi equals to ith value, means each term of the data. So let's understand it with one example. Suppose we have a data of 10, 20 and 30. So for Z-score normalization, we need a two things. First is a mean. So suppose this data is equals to A. So we'll calculate mean A is equals to n by 2th term. Yes. So here n equals to 3 by 2. So term equals to 1.5. We round off this value, then it equals to second term. So here the second term is 20. So mean is equals to 20. Now the second thing is required is standard deviation. So for standard deviation, we have a equation is in under root 1 upon n minus 1 sigma equals 1 to n xi minus x bar whole square. So let's apply this value on equation. So first 1 upon n minus 1 equals to 3 minus 1. We have a data value like 10, 20, 30. Yes. So now as per the equation, it is sigma I equals to 1 to 3 xi minus x bar whole square. So let's apply it. On that equation. So first value is 10, xi means x1. So here the value 1 is 10 minus mean value is 20 whole square plus 20 second value minus mean 20 whole square, and then third value 30 minus mean 20 whole square. Yes, so let's evaluate this equation. 1 by 2, 10 minus 20 minus 20 square, 0 square and 10 square. So it becomes 1 by 2, 100 plus 100. So now it becomes 200 divided by 2, then it equals to 100, and root of 100 is equals to 10. Yes. So here standard deviation equals to 10. Now we have value of standard deviation and mean. So now let's apply on normalization equation. The normalization equation is V minus mean A divided by standard deviation. So V is equals to V is equals to our first value is 10. So 10 minus 20 divided by 10. So then it equals to minus 1. For second value 20. 20 minus 20 divided by 10, then equals to 0. And our third value 30. It is 30 minus 20 divided by 10, then equals to 1. Yes. So we have our data range 10, 20 and 30, and we will normalize the data value into minus 1. This is the first answer, second answer and third answer. So minus 1, 0 and 1. So this is how Zscore normalization is worked. The third method is decimal scaling, and the equation for decimal scaling is V dash is equals to V divided by 10 raised to k. Here k is equals to maximum digit number. So let's understand this method with one simple example. Suppose we have a data value range is minus 999 to 99. Yes. So we have our task is to normalize this range with decimal scaling method. So first task is, or the first step for decimal scaling is find the value of k. Yes, because we have k is unknown in our equation. So k equals to, here take the maximum value from that range. Here the maximum value is minus 999. So this is a maximum value and this is a 3-digit number. So this is why the value of k is equals to 3. Okay, so suppose we have a data range is 1024 to 0. Then the maximum value is 1024. So at that time k equals to 4. So this is how k is defined. Now we have the value of k. Now let's put on all that value into the equation. So we have a range of 999 to 99. Yes. So for so to normalize this range, we have equation v divided by 10 raised to k. Then v equals to minus 999 divided by 10 raised to k. Here k equals to 3. So 10 raised to 3. So is equals to minus 0.999. And our second value is 99. So we'll put this in our equation. So it becomes 99 divided by 10 raised to 3. So it equals to 99 divided by 1000. So the value is become 0.099. So our new range is become minus 0.999 to 0.099. So now, this is how we can normalize our data value with the normalization techniques. Thank you so much for listening. Have a great day.